Ahoy, matey! We got some comparing functions that we're going to be talking about today. So let's go ahead and get started with that. Our first example, we have 3 trains, A, B, and C, leave a train station at the same time. And so here is all the different data about those trains as they leave the station. What we're going to be doing is comparing the speeds of each of them. To compare the speeds, we're going to look at rate, okay? And so rate is also known as the average rate of change, and with linear functions, that is also your slope. So what we're going to go ahead and do is we're going to start with this first one. To find slope, remember it is going to be the rise over your run. So my rise, if I take a look at my y-axis, each interval moves by 20. So we go up 20, 40, 60. So that was up 60. And then my run is my axis, looking at the axis intervals, they move by 1 hour. So we have 1, 2 hours. We're going to simplify that. That is now 30 miles per hour. Okay, next we have our equation for train B in slope-intercept form. So that means that slope is given to us. It is 45 miles per hour. And the last one, train C, is in a table. So we have to look at the, figure out slope from the table. So remember our table is x, y. So if I want to compare and think about slope, we can start either with the x or the y values. Doesn't matter. If I start with the y from 105 to 210, that's an increase of 105, 105, 105. So each one of these increased by 105. Oops, that's my numerator. And they also increase by 3 hours each. When I simplify that, 105 divided by 3 is 35, again, miles per hour. So compare the speeds of the train. Well, doesn't it seem like train B is traveling the fastest at 45 miles per hour? So let's go ahead and write that down, that train B is the fastest. Then train C, and train A is the slowest. There we go. Notice how it's a sentence. Key thing with what we're working with. Okay, let's try example number 2. We have the equation, y equals 11x represents the calorie Jake burns when cross-country skiing, where x is time in minutes, y is the number of calories. The graph shows the calories he burns while playing basketball. Which activity burns calories at a faster rate? Explain. Okay, so what I'm going to do real quick, so this is basketball, and I'll figure that in a little bit, but for skiing, I'm just going to write this down. Skiing is y equals 11x, where if I'm taking a look at 11, that's what we're comparing right now, it is going to be 11 calories per minute. Thanks. Then we have basketball. So for basketball, we're going to go ahead and take a look at rise over run to figure out the slope. We are going to go up 1, 2, 3. So each of these intervals were 500. So it is 1,500. And going for my run is 1, 2. And that is, each interval is 1. And so if I simplify that, it's 750 over 1. But notice that this is calories per hour, when skiing was calories per minute. So before we can compare these two values, we have to convert this to minutes. So maybe I should have done my work down here, so I apologize. So if I have to take my 750 and divide that by 60 because there's 60 minutes in 1 hour, now I have 12.5 calories per minute. Okay, and so now I can compare the two between basketball and skiing. Okay? So, which one burns at a faster rate? Well, it's going to be basketball. Okay? And let's go ahead and write that down. So basketball burns more calories at a rate of 12.5 calories per minute. Okay? Explain, well, that's where we can say skiing only burns at a rate of 11 calories per minute. Okay? So that's pretty good for our explanation. Hey, this last one, we'll just do this next time I see you in class. Okay, so let's go ahead and take these notes and flip it over. On the back here, this is a function notation review. So what we're going to be doing is just reviewing some simple function notation. We're going to expand it, make it a little bit more challenging, and then a story problem at the bottom. Okay, I know some of you have struggled with the story problem, so we're going to review that. So anyway, doing just, a review here at the top, I give you a function. I give you x minus 6 over 2, and we have to find g of 20 and g of 0. So when we do this, we're going to go ahead and put 20 in for x and rewrite the rest of the equation. Then we'll go ahead and simplify. So g of 20 is equal to 14 over 2. G of 20 is equal to 7. Okay, so just again simplifying. And I'll go ahead, we'll do this next one here real quick, where we have g of 0, same thing, we're going to put 0 into our function. Okay, so this is the input that we're doing. We're inputting 0, and then we're solving to get an output. So as I simplify, I find out that g of 0 is equal to -3, so -3 is my output. Okay, example number 2, or exercise number 2. So now I give you 2 different kinds of functions, and we're going to find the value of each. So this time, when I work with my f of x function, I'm going to substitute h plus 9 in for x. So what that's going to look like is 2 times h plus 9. And then I rewrite the rest of the equation, minus 6. And then I simplify. So 2h plus 18 minus 6. And I simplify by combine like terms. I have 2h plus 12. And so that is f of h plus 9 is equal to 2h plus 12. Okay, let's go ahead across, and then we'll work with our function of g of x. So this g of x function, this time I'm going to substitute 3y in for x. So what that's going to look like is 3y minus 2 times 3y squared. Okay, and so we're going to remember order of operations. We have to do exponents first. So 3y squared is 9y squared. Okay, so remember, we multiply it by itself 2 times, so 3y times 3y is 9y squared. We'll keep simplifying where we have 3y minus 18y squared. There's nothing more that we can do to simplify because these are unlike terms. One has squared, the other one does not. So I have g of 3y is equal to 3y minus 18y squared. For c, this one, we're going to just put 7 into our function of f of x, and then at the end we're going to subtract by 9. So what I mean by that is we'll rewrite that function 2, but instead of writing x, I'm going to write in 7, the rest of the function minus 6, and then that minus 9, this minus 9 goes in at the end. Okay, and so we'll go ahead and simplify. So I have 14 minus 6 minus 9. 14 minus 6 is 8. 8 minus 9 is negative 1. So f of 7 minus 9 is equal to negative 1. Okay. And then the last one here is g of 7 plus g of 3. So we're going to use both equations as we evaluate in function notation. So what this is going to look like, we will have our function of g of x. I'm going to substitute 7 in for x minus 2 times 7 squared plus, and then my f of x function, it'll be 2 times 3 minus 6. And then we just simplify. So 7 minus 2, well, 7 squared is 49, plus 6 minus 6. Negative 2 times 49 is negative 98, plus 6 minus 6. My last step, we're going to just add it up going across. So 7 minus 89 is negative, I said 89, 98 is negative 91, and then we have 0. So we have negative 91, and that's equal to g of 7 plus f of 3. Okay, and so we'll just do this story problem together the next time I see you in class. So that's it for these notes. See you next time. Over and out.